Okay, continuity in plain English, generally, what does it mean? Continuity, what does it mean?
It's any function that can be graphed without lifting your pencil.
That's right. Okay, you can graph the entire function without lifting your pencil. That's continuous. That's continuity. There are, so last night video notes, okay, we talked about how many types of discontinuity? 4. Okay. Number 1, what was the first type? A hole. It's a removable. What about calculus definition? Right next to the word removable, it says limit. Chanel?
The limit of x approaches c if x exists, but not equal to x.
Right. Okay. So you have a hole when the limit exists. That means the right and the left is approaching the same location, but the algebraic value is not the same as your limit. Okay. And then number 2. What was number 2? Yeah, infinite, right? Discontinuity. In algebra 2, what was it called? What was it called? Vertical asymptote, right? In algebra 2, it's called vertical asymptote. Now, infinite discontinuity, is that a removable? No, it's not a removable. Now, based on your calculus definition, what does it say?
It doesn't limit of f of x does not exist because limit of f of x when x is approaching c from the right side is plus or minus infinity, or
the left side, right? Well, what was the definition of vertical asymptote? It's the same thing here, right? As x approaches c, either from the right or the left, okay? The limit approaches what? Either positive infinity or negative infinity. Okay, so that's the definition of your vertical asymptote. Now, the third one and the fourth one are something brand new. The third one is called a what? A jump. Okay, that means the limits coming from the right and the left independently, they do exist, except they are not what? Equal to one another. Okay, and oscillation is that because it moves so much, it changes so much, you can't really pinpoint an exact height coming from either side. Okay, so those are the review of last night. Am I right? Perfect. Let's do example 1. I think we can get to example 2, and then that's the end of our day. Example 1, find the points of discontinuity of 3a, b, and c. So here we go. First one, y equals x plus 1 all over x squared minus 4x. What are you going to do there? Factor, yep. Okay. So factor that out. You're going to have, on the top, we can't factor any further, so that is. How about the bottom? What are the factors? X minus 3 times the quantity of x minus 1. Beautiful. What do we do now to find the discontinuity? Remember, not all the time that you would need to use calculus to find what you need. You can also use old skills. Take the denominator and set it equal to 0 since you can't reduce. Okay, so we're going to take the denominator, x minus 3 times x minus 1 equals to 0. That means you have 2 locations, x equals to 3 and x equals to 1. Now, what kind of discontinuity is this? Are they holes? No. In algebra 2, how do you know when you have a hole? When you can cancel the top and the bottom after factoring, right? Will we be able to cancel these? No way. So you can't cancel them. And how are they called? Vertical asymptotes. So these are infinite discontinuities at 2 places. Okay. New ETs. I have to say discontinuity really slow. Okay. At x equals 2, 1 or 3. Now, really quickly as well, we want to check using our calculus theorem. Based on that, our calculus theorem said for it to be an infinite discontinuity, the limit as x approaches, we'll pick 1, we'll pick 3, okay? X equals 3 from the left, and the limit, or the limit as x approaches 3 from the right of our function should be what? should equal to what? Based on an infinite definition. Should equal to infinity, right? Or positive and negative infinity. Would you guys agree? Okay, so let's check to see if it works. Let's pick the right side. X approaches 3 coming from the right. How do you know if it approaches either positive or negative infinity? Which one is it? What do you do? This is easily an exam question. What is the limit of this as x approaches 3 coming from the right? What would you do to find the answer? Is it positive or negative infinity? Or if it's infinity at all? What do you do? Yeah, plug in something a little bit bigger than 3. Okay, like 3.1, right? If I plug in 3.1 on the top, more than 1 or less than 1? More than 1. On the bottom, okay, if I plug in 3.1, would you agree that this is a small positive number? Right? Times 2, about 2. So what's happening when you have like 0.000001 times 2? Still very small, right? Something bigger than 1 divided by something still very small. What's happening? It's getting towards infinity. So for this one, it's getting towards infinity. So right now, does that qualify, or would that help us check that this is a vertical asymptote, aka infinite discontinuity? Yes or no? Yeah, for sure. Now, how about the other side? When x approaches 3 from the left, what would you pick? Yeah, 2.9. On the top, is that still positive greater than 1? Yeah. On the bottom, now be very careful. On the bottom, you have 2.9 minus 3. Positive or negative? Negative. Negative. Then 2.9 minus 1. Positive. A negative small number times a positive, let's say almost 2. What happens? Small negative. Does that make sense so far? Now you have something bigger than 1 divided by small negative, like negative 0.00002.
Or a small negative.
It's going to go towards what? Negative infinity. Okay, so that's how we check whether it fits the definition. B, what kind of discontinuity is that? It's a whole? Yeah? Okay. What's the definition of a whole? What is the definition of a whole? Limits exist, but not equal to f of x, right? Okay. Okay, test question. What would you do? Would you have to decide out of the 4 kind of discontinuity, what would you do first? If it's no whole, does it have to immediately be a vertical asymptote? Can it be a jump? Can it be an oscillation? Usually, let me give you a hint right now. An oscillation has to do with a trig function, because you know a trig function goes like this. Yeah. Okay. All right, so now you have 3 choices. Narrow down. Process of elimination. When in doubt, what should you do? Graph it out? Okay, let's graph it out. Okay, don't be scared of graphing. What do you even do to graph? I'm going to make a table. What value can you pick? How about this? What value can you not pick? 0. But can I pick something close to it, like 0.01 or 0.1? Good. Let's pick 0.1. Here we go. 0.1 on the top divided by absolute value 0.1. What is it? 1. I want to pick 99. What's the output? Also 1. Okay. How about I want to pick 1,000? Also 1. Okay. So 1, 1,000. Would you agree that I'm going to have a hole right there? Because I can't pick 0. But everything I pick, it's always 1 on the right side right now. But I should also test the left side, right? Like negative 0.1. All right, what happened when I pick out negative 0.1? Is it still 1? No, it's what? Negative 1. And then how about if I pick negative 99? What is it? Negative 1 still. So, would you agree I have a hole right there, and it goes like that? Okay. So right now, does the limit exist at 0? No. So can I eliminate the hole? What's next? A jump. You're right. Okay. When you graph it out, you can see right away. It's definitely a jump at x equals to what? 0. What's the calculus definition of a jump, guys? What's the definition of a jump? The limit as x approaches what? C in our case is 0. Is that okay? Coming from the right of our function does not equal to the limit. That's right. Okay. So it exists independently. They just cannot be the same. Okay. C. It's a piecewise. Where do you think the problem is at? What x value? 0. Okay, the problem is really at x equals to 0. So, is it an oscillation? Is it a jump? Is it a hole? Is it an infinite? Is it a hole? What would you need to test to see if it's a hole? Should we graph it out to have a visual, and then we do algebra? Okay, let's graph it out. I'm going to start with 0, okay? And then I'm going to have a whole, an open circle with 0. 0 times 3 minus 1, what would that be? Negative 1. And then it says greater than 0, so I'm going to pick 1. 1 times 3 minus 1? 2. And then that's a straight line, yes or no? Then the second one, I'm also going to pick 0. What happened when you have e to the 0? Negative, I'm sorry, it's 1, but 1 times a negative is? Negative 1. And I'm going to pick negative over here because it's less than. What happened when you have negative e to the negative 1? What would that make you? Is that the same thing as 1 times what? 1 over, I'm sorry, negative 1 times 1 over e to the positive 1? What's an equivalency of e? Yeah, 2.718. Would you agree that's about 1 times a third? About. I'm just going to approximate my dots anyway. So would you agree that's about negative 1/3? Bless you. Okay, so that's about negative 1/3 right there. Will this output be greater than 0 ever? Would it ever go above the x-axis? No? Okay. Some of you don't know. How about if I test out x equals to negative 5? Since that's all the dots I have. I mean, tick marks I have. X equals to negative 5. That means it's negative 1 times e to the negative 5. Is that okay? Oops, negative 5. Is that okay? That's really negative 1 times 1 over e to the 5th. Is that ever going to get above the x-axis? No. Okay. So is it a straight line? No? It's like that? Okay. Okay. So now, look at it. What is it? Based on just graphing alone. It's a hole. What's the limit definition of a hole? The limit as x approaches, in our case, the problematic location is 0. Does it exist? Of f of x? What is it? What is the limit as x approaches 0 for our function? Negative 1. Okay. So the limit exists. But does f of 0 exist? No. So that's the definition of a hole, right guys? The limit exists, just not the same as your algebraic value. So this is a removable, aka a whole. At x equals to 0. Okay, so that's how we determine the type. Last example, and then I'll let you loose. Example 2, here we go. Use the function f, define and the graph below to answer these questions. A, B, C, D. Look at that. There's a piece Y. That's a lot of pieces, right? Look at that. I already have I grabbed it for you. Let's answer part A. Does f of 1 exist? If you said yes, what is the value? Yes. F of 1 is 1. Very good. Does the limit 1? Yeah? What is the limit? Oh. Limits as x approaches 1 of f of x2. Are those two the same? No. So by definition, is it continuous? No. If it's not continuous, then what kind of discontinuity is that? Is it a jump or a hole? Oh, what's the definition of a jump? A jump is when the limit left and right do not exist. Based on letter B, does it exist? Yeah. A hole is when it exists except that it does not equal to the algebraic value. Would you guys agree? So right now, this is when I say it's a hole or a removable. Okay. A hole at x equal to 1. And this is an egg roll.